As many things, as very often it happens in life, no, actually I'm okay. A lot of positive things, a lot of positive outcomes come when there's a good balance between demand and supply. I think we all know that, be that personal life or financial life. And typically when there's a slightly higher demand than supply, then maybe that's the optimum balance. If we take that paradigm, if you like, or that metaphor, and we translate it to our industry, and more specifically to the industry needs in terms of vessel operation versus technology trends, and if we replace demand by what the industry requires at this stage, and if we replace supply with what technology trends are actually relevant and available for us, we can see that on the left side you have things like minimum downtime, reduction of operating expenses, compliance, and a lot of others, but I think I'll stick with these three, which are the essential items that a chief operating officer from a shipping company would tell you. And on the right-hand side of the balance, you see technology trends that we've listened and we've heard a lot about during the day, like smart sensors, Internet of Things, advanced telco, advanced computing, be that in the form of cloud computing or more CPU power on board, and of course big data analytics, which is also a big mega trend in terms of technology. Now if you sort of put everything together, a lot of people are combining the needs and the available technology and are talking about smart shipping. Again, a topic we've heard about quite a lot in different contexts, of course, but a trend that is actually becoming part of our day-to-day language. Now, the experts, some experts in the field, again, based on the same pretty much technology enablers that I won't mention again, are talking about the smart shipping era, and in fact they're saying that the smart shipping era has actually started and is here already. So the gentleman that you see here, Mr. Martin Stopford from Clarksons, not only says that, but goes on to claim that the focus of smart shipping is actually not on the design of the ships, and consequently one could argue the engines as well, but on the way we actually operate them. So it's the way we use them that is more and more becoming the essence of what smart shipping will be about. And that's what the technology enablers will help us optimize in a better way. This is not to say that the design is obviously out of the picture, but that's an ongoing, if you like, muscle that the industry has been building for years. It's the operation that we need to actually extend. Now, again, a controversial subject. A lot of things have been discussed. Unmanned, autonomous ships. I think it's a long-term vision, maybe a mid to long-term vision, but it's certainly something that the industry is using as a convergence towards the future in order to justify, if you like, the parts of the puzzle. So in that context, I'm also using it and saying that before we reach that level, we have to make sure that each of us, from the standpoint that we operate under, we need to focus on what is realistic, short to mid-term, especially in order to accomplish the milestone of the autonomous ship. So if I go a little bit more focused on the business that we operate in, and in complementing what the others have said for fleet performance, vessel performance, etc., I'll start talking a little bit about engine performance. Now, the standard of today's, if you like, a standard shipping company looking into engine performance today follows typically, and this is from the experience that we have working with our customers and cooperating with them in that journey, three different steps, three concrete steps. So step number one is the onboard data collection. That can be a manual process where engineers on board are actually collecting data in Excel forms or a similar logging procedure, or a real-time online system that collects data, but that's the first step. Then these are actually transferred and sent to the shore office, so the headquarters of the shipping company, where they're actually analyzed in some way and form at different levels of if you like, depth and complexity of the analysis, but nevertheless, they have to be compared to some sort of a reference state in order to judge if things are going okay or not. And this is what typically leads, ideally, I would say, into performance evaluation. And I say ideally because it's not necessarily the outcome of what a typical shipping company is actually achieving today, but this is the vision and this is the will, giving things like diagnostics, performance optimization of the engine, etc. Now, technology today is allowing us to go a little bit further than that. So from the vessel to shore office analysis and conclusions, and then feeding back the loop for actions on board, we can go, I think, to the next level. So from an offline onshore world, we can actually move to a real-time on-board era, and that's actually achievable through technologies that we will see in the next slide. So the difference between the previous slide and this one is that, as you can see, the analysis can actually take place on board. So we're talking about a real-time data collection, a real-time analysis, of course, based on work that has been done already before the system is installed on the vessel, which leads on board to performance evaluation and adequate support for the onboard crew. Needless to say that the loop closes always with the headquarters of the shipping company, so they do remain in the loop as it should be. Now, we've talked about the process. If we look into the key ingredients for success to reach that level, we see it as a three-pillar, if you like, or a three-way street here. So the first pillar is data themselves. Data in terms of collection, in terms of the smart sensor technology as such, in terms of the signal processing on board, in terms of the frequency, the clarity, the integrity of data. A lot of the speakers have talked about that as well. So that's the first pillar. The second pillar is the analysis part. And the analysis, we believe that one has to take to make sure that apart from the statistical, if you like, or big data analytics world, which indeed is a great new tool, very helpful for us all in the industry to analyze, one should not forget the engineering side. So the physical models of how things work based on core principles of engineering should always be part of your overall story, complementing the big data world. And the third pillar, which we should never forget, according to our philosophy, is the human expertise. And by human expertise, I start in the context of our work in the engine world with the engine developers. So the engine designers and the engine developers must be part of this, by definition almost. And I think it's clear. I don't think I need to elaborate more on that. But complementing that, it's the onboard crew and the the onshore expertise of the superintendents by the experience that they have in operating their vessels. And I think when the three pillars actually meet, so the cross point between all these three is actually the optimum way to go forward. This is the way we see the world from our perspective as a company. And I must say that we were lucky and happy and honored to share the same philosophy with a key player in the market, a leading innovator in terms of engine design, namely WinGD, Winterthur Gas Diesel. Some of you might not know the new name of the corporation, but if I tell you Wärtsilä two-stroke and further back Sulzer, I think everybody will be familiar with the history, which indeed is serving the merchant shipping since the 19th century, so to speak. So we are happy to, in fact, also announce it today publicly for the first time in the Greek market, that we are co-developing an engine diagnostic systems for their engines, which will aim at the following objectives: minimizing, ideally avoiding, downtime through prediction of component failure on the engine, making sure that the engine is operating under the most efficient way possible, supporting the customers on board with troubleshooting should something actually come up and be diagnosed as an issue. And last but not least, the engine developer themselves getting feedback out of the operation phase of in a more structured way, of course, because this is something that has been happening, but in a more, if you like, structured and methodical way from the engine operation itself. So just to go a little bit more into detail, you can imagine a system where all the signals from the engine control system are actually collected, and as I said, relevant process of the signal itself has to take place, analyzed. Again, we've discussed on how this will happen, and then that would eventually lead to engine diagnostics down to the component level, performance optimization, etc., including actionable items for the onboard crew, for troubleshooting, for maintenance and repair planning, potentially, as well as training on the job. And as I said, last but not least, all this piece of information will be fed back to the engine designers in order to keep feeding the loop and improving designs, etc. Now, we're very much in the very early stage of this, so it's early days, yet we do have some early prototypes to share with you, not necessarily to tell you that this is how it will look like, but mostly to give you an idea of what a system like that may offer to the onboard crew. So here you see what we call a home screen, so if you like a dashboard of the main screen that the onboard crew will see, and on the left you see various subsystems that can go into more detail. Engine diagnosis and performance might look something like that, where you follow the trends of certain parameters that you measure online, and based on the performance versus data analytics and versus physical models, you start seeing, the coloring tells you something in this case. Down to the component level, as I said, all the various subsystems of the engine will be monitored separately, again, through capitalizing on the engine experts' know-how. The example of the fuel injection is shown here. And as I said, should a problem come up or should a recommendation is needed for the onboard crew, a troubleshooting module will also assist them in going to an actionable item. And I think I'm reaching my time limit, so I'll close with a few bullets on conclusions. As I said, we believe smart shipping era is here, so we should all embrace it. And when I say all, I mean the whole industry, from whatever context and hat we're wearing, we should all embrace it. Our belief is that we should walk before we run. So yes, we have a long-term vision, but we should start with realistic goals, make sure that we use the best available technology in the best available way. And I think if I were to leave you with one, let's say, a statement from our side, I think we should not forget technology is only an enabler. We must combine technology with physics and basic principles of engineering, as well as human expertise. Provide, obviously, actionable information and useful benefit for the operator. And we should never forget that that's who we work for. So we should always get the customer points as part of the solutions we're building.